let's borrow 'em. I'm just giving out my notes for fundamental engineering. Just deal with the chemistry section. I was gonna do probability, but probability doesn't even match my category. I like when I do my freaking botany and geomatics and my aviation and then ending off my farm technology and then farm engineering. I might do probability because you gotta do probability for ballistics and the probability of trajectory. But other than that, I would never use probability. Well, yeah. I would never use probability for anything else other than the standard norm that require I mean need to. So with that being said, I would never use probability for anything else other than that. Mm. So right now for fundamental engineering one notes, I'm gonna post up a link. Don't mind the handwriting because I was rushing it. So yeah. This is just basic. This is simple stuff we should learn in middle school. I mean, depending on where you go to, because I hate private school, as y'all know that they don't have good education. They have better education in public, but you still had to be on an 18 and BT. Anyway, hold on. Alright. Hold on, don't like when the next match come up, don't start it. I'm gonna kick this random out. Oh, I don't even know. Anyway, Marvelous, where you go? Why you leave? I didn't do nothing. Oh man. Hearts, I'm in a lobby with them and I'm the host. You can join in if you want. Hearts, this is ballroom. I'm in a lobby with everyone else here. Man, just come in our lobby and you be good. But anyway, as I stated, for atoms, for atoms, proton, neutrons, and electrons, protons are positive charged, electrons are negative charged, and neutrons are no charge. And with that being said, an ion is when there's a uneven number of electrons and protons. So we're gonna get this out of the way. And when I go to school, ions are when there's an uneven protons and electrons. They are uneven. Usually, when you gain an electron, you gain a negative charge. So it's a negative charge ion, and it have an electron in its orbitals. It has actual orbitals in a shell of configurations or there's a positive charge freaking ions when it lose an electrons, meaning it lost a part of its negative charge. So electrons, negative charge, protons, positive charge. Now, I wasn't getting into this later, but I'm just gonna say it now. For protons, you're not gonna really lose a proton, but if you did lose a proton, it can convert to isotope. But we're not gonna get too far in that. The main reason stated when you lose an electron, it's a positive charge because it's harder to store a proton than it's electrons. Because most of the time, to break covalent bond or hydrogen bond or ionic bonds, you apply a negative charge to it. And most of the time, it doesn't destroy the proton; it just takes away a negative charge. Negative charge. So make that note. Now, in an element that has, when you look at the notes and stuff, when you see an element symbol or number, yeah, I hate it. On the top left corner as a subscript like 5 power 2, if you look to the left of it, is there a superscript for that? That left-handed superscript is usually the number of mass for that atom. Now, if it's right, it's usually the oxygen state, meaning if it has been oxidized and how many oxidation the process takes. Now, I said I was going to throw a project application while this is perfect section. Trying to think of ions, but for ion wise, if you put water by itself, it's more of a neutral pH. But if you apply salt to it and you hit it with electrolysis, the hydrogen molecule will become an ion because it will lose electrons, and that will break the covalent bonding of the H and the O, which is hydrogen oxide. And if you collect that, you can get hydrogen gas, which is how they use in HHO in vehicles. So that's just an example of ions, whatever. So now oxidation. It's hard to put a practical application like the tool, so I'm going to use it. The oxidation superscript is usually measured by a standard because US have their own standard, and when I went to UK, they have on a standard. Usually, carbon 12 with an oxidation of 12 is different from UK that have an oxidation of 8, but even though they mean the same thing. For a practical application like this, usually you need a super telescope, or matter of fact, this is a microscope and a freaking other chemicals to apply to the metal, and based on the degree of that metal turn, you can tell how far it is or how far the oxidation state is, and that would give you the superscript number. Now, the problem with that is you require even more power scope to look at the configuration of it, and you have to use a vacuum chamber, which is why I say it's harder. All right, it's time, guys. It's time to lose. I'm gonna do it myself. It's time for me to claim my title. I'm better with everyone. I'm better with everyone, but y'all still worser. So let's do this. All right. All right. Anyway, a acid. Most of the metals out there that are acid are uh freaking most acid oxides are nonmetals when they get in water. So if you add a nonmetal to water and you oxidize it, it's become acid, the water itself. And for example, nonmetal silicon is considered nonmetal. Or it's harder what you put. Whatever. If you It's hard to say because certain chemical processes are different. But anyway, for all nonmetal elements of the purity, if you put it in water and you oxidize it, it will make the water act acidic. Acidic. That's the proper word. There we go. That's your word. Now, alkaline. If you take a metal element and you oxidize in water, the water become alkaline or base. Metal oxidizing water, non-metal and oxidizing water. Now, oxidizing is when you add an oxygen element to that substance, which is why water is a great solvent. But it depends. Oh man. Oh yeah, hot cake. Oh dang. And then there's oh man. Oh man. And freaking substance like carbon dioxide 2 or sulfur oxide freaking 2, they're slightly acid. When I say oxide, usually when there's a solid element, a metal element, or a non-metal that can turn into a gaseous state and you oxide it, depending on how you oxide it, become a dioxide. Usually dioxide meaning two elements of oxygen that have been oxidized. Or, oh my boss. Hold up. Not two elements. Freaking one molecule of two atoms, basically. Yeah. Anyway. Oh my, I'm getting killed here. Now, an isotope are atoms that have the same atomic number, but they have different numbers of neutrons. For example, freaking um take hold on, nah, we're gonna say that, but crap. Oh my balls, okay. Take freaking carbine. You can have isotope or carbine. There's carbon 6, carbon 8, and carbon 13. When I say carbon 6, carbon 8, 13, that carbon have the same atomic number, meaning have the same freaking atomic mass or the same mass, but hold on, crap. What was all about? Alright. It has atomic number, meaning the same number of protons in it, but they can have different atomic mass. Or actually, I was going to advance. An isotope anything that can have different atomic mass or a different atomic number. That means carbon can have a different amount of neutrons in it, but the electron and proton can still be the same atomic number. The reason why I say that's more advanced because certain elements, if you split them off or do a freaking fusion, if you do a fusion with certain elements, it will be an isotope. Usually you want to learn it to your fourth year in chemistry or nuclear physics or freaking bioengineering or medicine, whatever. And explanation of isotope is practical application for, take the example when they make a car. The fuel in the car had to go through an isotopic process to properly work. Now, I'm skipping a huge amount of steps, but if you take, I don't know, take diesel for example. Diesel, lead, unleaded, and freaking, oh my, and freaking regular fuel or coal fuel, when you heat it, the main thing I tell them from the different state is how heavy the lubrication is, not the combustion. This is how heavy the lubrication is. The main reason why large vehicles need that heavy amount of lubrication because they have more friction on it. What isotopes come in is during the process of making the fuel, you have to use 3 different phases of isotope for diesel and 1 different isotope for lead. Now, unleaded is a special case because there's super unleaded and regular unleaded. And super unleaded will also need 3 isotopes to make. So, now we're not going to do calcium oxide, magnesium, but we know. I already did that on my physics video. But anyway, y'all already know that in an atom there's protons, neutrons, electrons. Got it. And in those atoms there is a electron cloud. And in those electron clouds there are different levels. If y'all want me to do a tournament, we can do a tournament. Alright. But in an electron cloud, there's different levels of the cloud based on the element or the atom, because that element is a raw state. Yeah, take it back. An atom. I don't remember that. An atom have an electron cloud of it. And that electron cloud, they're each different level based on that element. In one electron cloud, such as hydrogen, there's usually 3 electron clouds, depends on which one it is. And in those 3 electron clouds, they usually 2 s orbitals and 1 5 freaking orbital, 5 o orbital. Now, we already discussed this in physics while I did my video on it. I still did this on my other channel. It has way more on it, but there's s orbitals, there's p orbitals, there's d orbitals, and f orbitals. And if you're going for quantum physics, there's like 300 other orbitals. But each orbital have a maximum number of electrons in each of those orbitals. As I said, this is important for product application use, that you require a certain amount of power or required materials to break each of those orbitals down. For genetic engineering in a human body, there's covalent bonds, hydrogen bonds, there's ionic bonds, there's sodium bonds, there's phosphate bonds, and everything else. Now, when you do medication or medical stuff, which I bring this up because in order to make medicine, most medicine operate with the human cells that end up operating on a genetic level. In other words, you need to make that medication where it will affect your cells. In other words, it will end up affecting the orbitals within your cells. Middle finger to religion. Yeah. But anyway, that's just fundamental engineering and stuff, so I'm going to stay on this. I'm out.